is now we have the distance between 3 and 5 and the other ones. And we have to decide which clusters are closest together, because our next step is to do that. Well, turns out that 3 and 5 have a distance of 0.07, and 6 is 0.07. So the next thing that happens is not grouping together 2 of the other points, but it pulls 6 into this group. So in my picture, which was randomly drawn 6 points, so this may well happen. What's the closest? If you're doing nearest neighbor, this one is pretty close to that one, right? So I'm not surprised that my next step is to group those together. And that's what happened right there. 6 got joined to the 3 and 5. And so it's a mathematical process. It's a computational process. No statistics. Only computer work. No if I get really out of control, I'll talk about fuzzy clustering. Fuzzy clustering involves some statistics and some assumptions, and is exactly that. It's fuzzy. Not a very scientific process. And some of my mathematical colleagues would take offense to the fact that I just said that. There's a reason it's called fuzzy clustering. That you sort of put the points together. Well, what does sort of mean? Well, that's why it's called fuzzy. What happens next is it looks like 2 and 4 got joined together. Because we had to recompute some things, but not all the things. We're going to group 3 and 4 together, or nope, 2 and 4 together. So now we're down to 3 clusters. Lovely. Keep going. We go from there down to 2 clusters, and in the end, we have 1 cluster. So it's a process. It's a computational process of starting with all the points in their own cluster and joining together the 2 that are closest, and then you keep joining them, and in the end, you'd have 1 cluster. This process is computationally simple. The computer loves it. Unfortunately, it doesn't tell us how many clusters we have. So in our 6 points, we have 6 clusters, 5, 4, 3, 2, 1. Oh, I don't know. All I know is that I did the process. This is the challenge. It's not going to tell me how many clusters I have. Intuition, I sort of talked about, this is partitioning. Nobody ever does partitioning. It's just the reverse. Start with all the points in their own cluster and start splitting it up. Are you going to get the same? Are you going to get the same backwards process? Not necessarily. Maybe, maybe not. Intuitively, there may be situations where it makes sense to do a partitioning method. But I can't remember ever seeing it in practice. And I've seen hundreds of agglomerative approaches used. So maybe it's just the kind of stuff that I do. That doesn't mean that you might not have a situation. You work in a different field than I do. Well, I guess I work in lots of different fields. But you could well be in a situation where you go, oh, I really want to partition instead. Maybe. Okay, these are SAS choices because these were made in the days when we did SAS in this class. But we'll do this the same things in JMP or in whatever software you're using. The SAS has a procedure called FastClust, which is a fast clustering procedure. that is the worst procedure that SAS ever wrote. It is terrible. And if that's the one, if you only learned not to use FASTCLUS in SAS, and that's all you ever remember, then that's good. I don't understand, actually I do understand what happened with SAS, but why it's still there. Maybe they took it out by now. But every new version of SAS, I'm going, did they take out FASTCLUS? No, they didn't take it out yet. They know that it's idiotic. You can talk to them. Go, oh, guys, why are you doing this idiotic procedure? Well, they're doing it because some person wrote the procedure back in 1942, and it's just lived there because no one's taken it out yet. Because SAS doesn't do that. They just leave it and let it sit there and drive people who actually do cluster analysis nuts, because someone who doesn't know what they're doing will do it. And I'll explain at some point, I'll give my diatribe on FASTCLUS. The only advantage it has is that it's fast. But if it converges to a terrible solution, why is that good that it's fast? It's true. It's fast. And if you do what's called k-means clustering, which I'll talk about, k-means clustering is computationally very hard. So the problem is that people want it to run fast. So some not so clever person, I should find out who this is someday and go, I've been making fun of you in class for 20 years. And go, anyway, it's a terrible idea. What they call cluster is hierarchical clustering. What they call a tree makes it's something called a dendrogram that we'll talk about coming up. It's a picture that goes along with with clustering that you will see in lots of papers. If the paper's doing cluster analysis, they're probably making a dendrogram. And yeah. So, and we don't have our picture yet because we have our famous MBA example. We have 100. Are we making fun of MBAs in this case? Sort of. So sorry if you're an MBA or whatever. We have 152 MBAs filled out a survey. If you can avoid doing where are the survey people? I really like data more than surveys. A survey is not data. And if you can avoid surveys, your life might be better. Collect information about the subjects, and if you can avoid surveying them. It doesn't mean that we don't do surveys, and the Department of Statistics makes millions? I don't know. We make a lot of money off of surveys, because surveys are just confusing, and there's so much. It's much easier just to get a blood sample from everybody and measure some stuff and move on. That surveying the people creates all sorts of trouble. So I don't know who surveyed the 150, somebody surveyed 152 MBA students. They filled out a survey, their preferences for 10 comparably priced cars. It's a perfectly logical, not customer service, customer desire survey. And you can imagine that the car people want to know this, right? They want to know the MBAs are going to buy cars their whole life. They're going to buy cars, and so if they have $30,000 to spend on a car, what are they going to buy? That's an interesting question, and the survey people are constantly trying to figure this out. Oh, why don't they have a focus group? So besides surveying them, you could select some of them to come in and talk to you about what they think about cars. That's what a focus group is. Does anyone do focus groups? It's like the opposite of statistics. On the other hand, it turns out that you learn something by talking to people about uh, how they feel about cars. Well, to a statistician, how they feel isn't relevant. Show me the data. But we did write a grant 2 years ago where the grant required that we do focus groups. And we're like, you gotta be kidding. But it was a big grant that we were asked to apply for. Fortunately, we did not get the grant, so we didn't have to do the focus groups. Thank goodness. No, I wanted to get the grant because we wanted the money, but we were a little skeptical about what we were going to. It would have been an interesting experience, put it that way. Yeah. In this case, in our case, it was with PCORI, the patient-centered people. The patient-centered people, they're patient-centered. They want you to meet with the patients. I want to collect the data on the patients. Actually, I want the biologists, other people to collect the data and give me the data. I don't want to go talk to them. That sounds scary. It's actually not. I'm sure it'd be fine. We're going to split up our MBA students into groups, maybe. Some miracle happened, and we figured out that we have 5 clusters. About 5 clusters. Don't know how that happened. We can summarize the data for the different clusters that we found. So we took this data, which is a survey. The survey, I don't know how many questions it had. Maybe it's a nice survey and it has 15 questions. Or maybe it asks them to rank